So now we're going to look at a very specific question. If we want to find the equation of a line, and we know it goes through the point of the intersection of another two lines. So we've got a point, and it goes through a point of intersection. Now, there's a long way of doing it. Now, I'll do that first of all. I suppose it's the way people would think of, first of all, for doing it. If we had to find the equation of a line, passes through the point of intersection of these two lines, but it also goes through the point 1, 2. I suppose the first reaction is, oh well, let's go and find that point of intersection. So we'll solve them simultaneously. Need the coefficients of either the x or the y to be the same. So I'll make the coefficients of y the same. I can eliminate the y's. I end up with x is negative 2. Sub that back in. We'll get y is 3. So now the question becomes, what's the equation of the line that goes through the point 1, 2 and the point negative 2, 3? We can now use our point slope formula. So slope minus a third, we have a point, we have a slope. Substitute it in and we get our line. I mean, it works, but it's a rather long way of doing it. There is a better way of doing it. And that's just using this idea. We know the point of intersection satisfies both equations. Okay? So if I substitute it into the, let's say the first one is a1x plus b1y plus c1, I must get 0. If I substitute it into the second one, a2x plus b2y plus c2, I must also get 0. So that must be true for the point of intersection. We want it to be true for a third point. Well, any equation of a line is simply some constant times x plus some constant times y plus a constant number. So all I have to do is multiply one of those general forms by some constant. And I just got to work out what the constant is that works for the other point. Because if when I substitute it in, it again comes up with 0, then I know it must lie on that line. So that's the basic idea behind it. So the question we just had, the two lines were 2x plus y plus 1 equals 0, and the other was 3x plus 5y minus 9 equals 0. It does not matter which one you multiply by the constant. Sub in the point that we know, not the point of intersection because we don't know that one yet. So 1, 2, we sub it in and we solve it for k. K is minus 5 on 4. Sub that back in. That is the equation of the line. Now, it looks rather messy written like that, so we'll tidy it up, multiply by 4 to get rid of the fraction, group the like terms. It's got a common factor of 7. I'll divide everything by 7 and we get the same equation that we got before. So that's the idea. It certainly saves a lot of time as well. That's not to say you can't use the other one, but be warned. If they have specifically written the question thinking you're going to use this idea, remember, using this idea you don't actually have to find the point of intersection. If you go and use the idea where you find the point of intersection, the numbers may not be nice. They might end up in all sorts of horrible fractions because they weren't expecting you to go that way. So endeth our look at Cartesian geometry, which means tomorrow we'll start looking at its partner, Euclidean geometry.